All right, so what we're going to do now is we're going to practice identifying graphs. Okay, what is the exponential graph? Or what is the exponential function that goes with a graph? And I'm going to show you a procedure that you can use that will help you to identify those graphs. Okay? All right, so let's go ahead and take this one. So this will be our first example. The very first thing that you should do, in my opinion, is identify where the asymptote is. Now, obviously, the asymptote is always at the x-axis, okay? But here's what's going to happen. In the next lesson, we're actually going to change that. These graphs are going to shift vertically up and down, and they're going to shift horizontally left and right. Okay, and so you should get in the practice of always identifying the asymptotes. The first thing we're going to do is we're going to identify where is the asymptote, and here's the asymptote at the x-axis, right? Then we need to know whether it's going through the point 1, 0 or 0, 1. Okay, now this graph is above the asymptote. Okay, it's above the x-axis, and 1 unit above the x-axis is this point. It's going through the point 0, 1. And because it's going through the point 0, 1, that must mean that it is not upside down. Okay, so it's either a normal graph or it is a backwards graph. It is not upside down, because we know that upside down would mean that it was going through the point 0 and -1. The next thing we need to know is we need to know whether it is backwards or whether it is the normal graph. Well, we can see that the asymptote is going off to the left, okay? Normally the asymptote goes off, or excuse me, the asymptote is going off to the right. Normally the asymptote goes off to the left. Normally we're flat to the left, steep to the right. Here we're flat to the right, steep to the left. This must mean that this function has a negative on the exponent. So it's going to be to the negative x power, okay? We know that it's not upside down because it's passing through the point 0, 1, so there's not a negative in front of the base. The last thing we need to know now is what is the base? Well, we learned how to do that before. We know that we need to go 1 unit over from where this point is, okay? By the way, I call this point the point. This is basically the central point of the entire graph. We're going to go 1 unit over, and then from the x-axis, from here, we're going to go up 1, 2, 3. Okay? And because at this point right here, now normally it's at 1. So for example, like 1, 2 or 1, 3, but in this case it's -1. The reason it's at -1 instead of 1 is because this negative on the x is going to reverse the -1 to a +1. Okay? But the distance here is 1, 2, 3, and therefore this distance represents the base of the function, which is 3. And therefore this is 3 to the negative x power. And I can prove this to you, what I just said. We're at -1 and 3, right? This is the point -1 and 3. Well, if I were to plug a -1 into there, we would have 3 to the negative -1 power. -1 is +1. That's 3 to the first power, and that's 3. Okay? And so when we look at this, we know that this, based on the base being 3 units above the asymptote, and based on it being reversed, okay, and that it's above the x-axis, we know that it must be base of 3, negative x, so it's f of x equals 3 to the negative x power. Let's try another one. All right, let's try this one. Why don't you pause the video and see if you can figure out on your own what this is the graph of. All right, so the first thing I want to know is this graph above or is it below? And is it going flat to the left or is it going flat to the right? Now I know the normal graph with no negatives on it is flat to the left and above the x-axis. Okay? This one is below the x-axis and it's flat to the right. And that means that this must have 2 negatives on it. This is upside down and backwards. Okay? So I know that this graph is going to be f of x is equal to negative something to the negative x power. Okay, it's passing through the point. I can see clearly here too, it's passing through the point 0 and negative 1. So since the point, that's what I call it, the point, since the point is below the asymptote, I forgot to draw on the asymptote. Well, there's the asymptote at the x-axis. Because the point is below the x-axis, it must be upside down. And because we're going flat to the right instead of to the left, it must be backwards. Okay, now we just need to figure out what the base is. I'm going to go 1 unit over from this point, 1 unit over, and then I'm going to go to the asymptote. So this is the line that I care about. Okay, and it's going to about right here. That's where it touches, right there. And I'm going to count from the asymptote, not from this line. I'm counting from the asymptote. From the asymptote, it's 1, 2, 3, 4, 5. Now I want you to, so this has a base of 5. But I want you to understand something here. There are a lot of students, and I want you to be careful about this, that when they start counting here, they'll say 1. 1, 2, 3, 4, 5, 6. They'll think the base is 6. It is not 6. Do not say 1 when you are at the starting point. When you're running a race and you're at the starting line, how far have you run so far? You have run 0. So at the starting point, you are at 0. So if you want to say something when you're touching the starting point, say 0. 0, and then from here to here is 1. From here to here is 2, from here to here is 3, from here to here is 4, and from here to here is 5. So the distance between here and here is 0, 1, 2, 3, 4, 5. This curve has a base of 5, therefore this function is negative 5 to the negative x power. Okay, let's do a couple more examples. All right, here's another one. If you want to, you can pause the video and try and figure out what the equation is yourself. All right, now I'm going to try it. I want to draw on the asymptote. You can see it goes flat right here. So I'm going to draw on the asymptote right about here. Keep going all the way over here, right? It's flat to the left, right? Flat to the left, so that's the same as normal. This is not backwards because it's flat to the left. Normal is above the x-axis. Well, this one is below the x-axis. I know that because it's passing through the point 0 and negative 1 below the x-axis. Therefore, this must be upside down. So I know that this is going to be f of x is equal to negative something to the x power, okay? Not negative x power. The reason it's not the negative x power is because it's flat to the left. It's the just like the normal is flat to the left, so no negative on the exponent. The only other thing I need to know now, I'm going to move this out of the way. The only thing I need to know now is how far is the graph from the asymptote one unit over from this dot, okay? Where x is equal to 1 in this case, okay? So from here, 1 unit over here, and from the asymptote, what is this distance right here? What is that distance? Well, that distance looks like it's between 2 and 3, but closer to 3. Well, I explained this to you in one of the previous videos. When the value is between 2 and 3, but closer to 3, that means that it's e, right? And so this is f of x is equal to negative e to the x power, okay? All right, let's just try one more. All right, here's our last one. Do you want to try and pause it and figure it out for yourself? All right, now I'll figure it out. I'm going to draw in the asymptote first. I can see it's flat to the left here. So there's my asymptote right there. Draw on the asymptote. Okay. I can see that the graph is passing through the point 0 and 1. Okay. So it's obviously above the x-axis. Also, it's going flat to the left. So flat to the left above the x-axis. This one is normal. It's the normal shape. No reflections at all. It's flat to the left, steep to the right, and it's above the x-axis. So there are no negatives on this particular exponential function. So this is going to be f of x is equal to something to the x power. That is all, no negatives. Now we just need to know the base. So to find the base, from this point we're going to go over 1 unit, and then we're going to go down to where the asymptote is, and we're going to start here. We're going to go up along this line right to here, okay? Up here, it's past this line. Down here, it's to the left of this line, so it must be right there. So from here, it's 0. It's from 0, 1, 2, 3, 4, 5, 6. The height there is 6. Therefore, the base is 6. Therefore, this is 6 to the x power. Okay? All right, so there's a few examples to help you with this. I recommend that there'll be tons of possibilities, tons of permutations, a lot of different practice problems on the practice quiz. So if you practice that a lot, you should get really good at this. And then what we're going to do in the next lesson is we're going to take what we know about this and we're going to add translations. We're going to shift the graph up, down, left, and right. And we're still going to have to identify whether it's above or below, upside down or backwards, and we're still going to have to identify what the base is. But we're going to add something to it, okay? Well, that's it for now, and good luck with that.